Assalamu alaikum. Up till now, we have seen data sets which included the values for just one single variable, such as the number of errors in computer programs written by students, the scores of students in mids or finals, or the time it took the students to complete a given programming task. In this week, we are going to discuss the bivariate data, which involves values for two variables which are varying together. So bivariate data involves two variables that are studied together. One variable influences the other, or both influence each other. One of the variables is the independent variable, which is presumed to be causing the change in the dependent variable, such as the calorie intake can be considered as an independent variable, which is causing change in the weight, which may be considered as the dependent variable. So if we increase the calorie intake, there's an expected increase in the weight. Similarly, the distance from home to school can be considered as an independent variable, which affects the performance of students in the school. Independent variables are also known as explanatory variables, and the dependent variables are known as response variables. When we talk of variables, we know that there are two broader types of variables, which we have discussed in one of the earlier lessons, qualitative and quantitative. The qualitative variables can be further divided into categorical and ordinal types, whereas the quantitative can either be continuous or discrete. For bivariate analysis, we can use one of these tools, which includes scatter plots, correlations, covariance, and regressions. The scatter plots are simple plots which show the relationship between two variables. And for that, we plot one variable on the x-axis, which is the independent variable, and the dependent variable is plotted on the y-axis. Here you see one example of the scatter. The actual data points are plotted as dots on the plane. So here, the values of independent variables are presented on the x-axis, and the values of the dependent variable are presented on the y-axis. These are the actual data points in your dataset. Scatter plots reveals quite a few things. सबसे पहली चीज, the type of relationship between the variables. So here you can see that there is an increasing or a positive relationship between the variables in this plot. अगर x की value increase कर रही है, तो y की value भी साथ में increase कर रही है. And this is revealed by a trend that you see by the plot, by the dots that have been plotted on the scatter plot. It also shows the strength of the relationship between the variables. So if the plots they are clustered together tightly, that means a very strong relationship. And if they form a definite pattern, that shows a strong relationship. And if they are scattered away from each other, that shows a very weak or sometimes maybe a non-existent relationship. It also reveals the presence of outliers, such as in this case, we can see a pattern, a line that can be drawn over these dots. Of course, उस line it's not going to cover all of these dots, but you still see a definite pattern. So that tells you that there is a relationship between these variables which have been plotted, which in this case are age versus the hours that a person is sleeping for. And you इस plot में we can clearly see that there is a trend, an upward trend, and the dots seem to be quite closely clustered here. And we can also find a few outliers, at least one over here. Similarly, in this next plot, you can see a trend which is not linear, but it is going upwards for the first half of the x values and then coming back downwards. और अगर आप इसके caption पे गौर करें, so you will feel that this graph quite realistically represents the relationship between the two. X-axis पे hours worked plotted है और y-axis के ऊपर overall happiness score किसी भी तरीके से calculation की गई, plot किया गया. So it is quite realistic that initially the number of hours you work, it increases your happiness. And after some time, there is a downward trend. Of course, the tiredness takes over and the happiness is converted into sadness. There is an, let's consider this data set where we have two variables. One is the profit against any products, and then the sales of those products. So we should expect कि अगर profit ज़्यादा है तो sales कम होंगी उसकी, और profit margin कम है तो उसकी sales ज़्यादा होंगी, because then the product would be cheaper. When we make a scatter plot of it, we take the profit as the independent variable, and the on the y-axis we plot the sales of those of this product. So we do it this way. We expect that if the profit margin is high, the sales should be lower, and if the profit margin is lower, the sales should be higher. But here we see that we do not find a definite trend. We do not see whether increasing the value affects increases or decreases the value of y, because you see the plots, the dots quite scattered all over the place. And we can also see a few outliers here, here, and here. But yes, we can find a group of dots which seem to be clustered here, and another group of dots which seems to be clustered here. And then a few dots which could be combined either in this cluster or in this cluster. So there are quite a few things that you can learn from the scatter plots. Sometimes scatter plots can have an associated trend line with them, which show the direction of the association between the variables, such as in this case, we have a downward trend. If the value of x is increasing, the value of y seems to be decreasing. So this is a negative relationship between the dependent and independent variables. And you can have an upward trend represented by a line going upwards. So if the value of y is increasing, x is increasing, the value of y is also increasing. So this is a positive relationship. The trend lines show whether the relationship is linear or not. So in this case, we had linear relationships. Here we have a nonlinear relationship because this line is forming a curve. And it may also reveal whether there is any relationship at all or not. So here you can see that you may not be able to draw a trend line because these dots are scattered all over the place. These trend lines are also used as for prediction as the lines of best fit. So we have this data plotted through this line, and now a value of x which is not included in the a value of y which is not there in the data set, we can extend this trend line to predict the value for y on that x value. So for example, we have x values up till 40, and we haven't seen the what would be the value of y for an x value which is 50. So we may extend this trend line. Of course, there are ways to do it. There are systematic ways to learn this pattern and then estimate, extrapolate it to find those points. But this can be used to find the values on the unseen x points. So if we try to compute what would the value be of the value of y against the point 50, we can extend this trend line to find that out. So this kind of analysis is used for prediction. So if you have a scatter plot, you need to learn a few things from it. Firstly, you need to find the direction of the relationship, whether it is positive or negative. In this case, we can see that the line is, or the trend is going downwards, and which can be detected by the increasing value of x are actually bringing the values of y down. So this is a negative relationship. We can identify whether the relationship is linear or not. So here you see that we see curves, although they're not very well formed, but it's not a linear relationship. Clearly, there's no linear relationship over here. Here we see somewhat linear relationship. Here is a very clear curve. These points seem to be quite scattered, but we do see some groups. Here, the points are quite scattered, and we may not be able to draw a trend line. The scatter plots can also give an idea of the strength of the relationship. If the pattern is very well defined and the dots are quite close to each other, this shows a strong relationship between the dependent and independent variable, such as in these two cases. This is a non-linear pattern, but the pattern is well defined and the dots are quite close to each other. They are clustered together. So these two graphs represent very strong relationship. While here you can see that the dots are quite scattered and the relationship is either very weak or non-existent. Then another thing that you can learn from the scatter plot is the kind of variability in the data set. If the scatter plot shows a fan effect, if these dots are fanning outwards, in either going upward or coming downwards, this actually shows that the variance in the data set is not constant. Here you see that the points are at the start of the graph, the y values, they're not varying much. The variance in y values is smaller. But as we move towards the higher values of x, the variance in y also starts increasing. So this is represented by a fanning or a funnel effect, a funnel shape that you see in the graph. This shows that the scatter or the variance in y is very smaller, from values from 80 to 90. It grows a little bigger from values of x from 90 to say 105, and then it becomes quite large. And then we also see an outlier over here. Scatter plots lets you identify the outliers. So in this scatter plot, you can see outliers here and one here as well. And then they can also reveal the groupings or clusters. So if you plot this in this scatter plot, you can find out that there might be a subgroup of data here, a cluster here, and one cluster here. So there are at least 5 or 6 different things that you can learn from the scatter plot.